Right, I'm just going to talk a bit about the P versus NP problem, which is Claymath Millennium problem number 4 on the Claymath website, okay? So P versus NP is from complexity theory, sort of the idea of computers and how efficiently a certain task can be achieved, such as encryption algorithms, things like that. So types of P, class P, can be completed in a finite amount of time, as in, imagine that you've got an extremely difficult encryption that can be cracked, it just takes a lot of time, and you know for certain that can be cracked, or that whatever task it happens to be can definitely be completed efficiently by a computer. And the opposite to this problem is an L problem, which means that rather than being able to be completed in a finite amount of time, it might take an infinite amount of time to complete, or it definitely will in the case of a classic L problem. And the problem is, with the P versus NP problem, NP is not polynomial P, but it's not L either. It's in between the two. Surprise, surprise, it's neutral, you see. And it seems to, at first glance, it might seem like there's a possible solution, but when you actually try and find that solution, it seems also that finding the solution may take an infinite amount of time to complete. Although it seems like it might be a finite problem, it may also be an infinite problem, and that's the problem with the P versus NP idea, basically. Like I say, imagine trying to count every atom in the universe. It might be theoretically possible to count every atom in the universe, we don't know, but if you try and actually physically do that now, then it could take an infinite amount of time. That's the basic problem. P versus NP, an infinite amount of time, a finite amount of time, and NP is in the middle. So basically we've got these problems such as, if you take a certain amount of routes around a city on a map, and add a certain amount of factors to that, and then it just gets incredibly complex. I can't think of a really good example, but there's a good example involving lists of students with conflicting or compatible interests on the Claymath website. It's like trying to map every single function of the human brain, trying to list every single possible function that a computer could have. Things like this that sort of at first glance seem like, oh well, perhaps we could complete this task, but when you actually try and do it, it could take an infinite amount of time because there's just so many of them, or there seems to be so many. That's the point. It's the seam that's the important here. And so far, nobody's been able to prove or understand properly whether types of NP problems actually exist or not, so to speak. There's also the idea that there may be a formula contained within these problems, as all the other Millennium problems, that might allow us to solve them simply, or in a finite amount of time, should I say. And that's the basic problem with P versus NP. My answer to the P versus NP problem is, you've got L, which means an infinite amount of time to solve a problem, P, polynomial, which means a finite amount of time to solve a problem, and NP, which is in the middle. It's not finite, it's not infinite, it's in the middle. Okay, and that's what NP means. It means the neutral point between finite and infinite. So it's no wonder that there's some problems that don't seem to be finite, sorry, I keep pronouncing that word wrong, finite or infinite. It's no wonder that there's a neutral potential in the middle, isn't there? Because there's two opposites, as you know, within the universe. Everything that you can possibly imagine or think of or create, any mathematical theory, including all the Millennium problems, obviously. There's opposites and neutral, okay? So you've got L, P, NP in the middle, and that solves the problem. There's 3 types of task, okay? A finite amount of time to complete, an infinite amount of time to complete, or neutral, the point between the two. Not one or the other. That's what neutrality means. And this is evidence of neutrality within the P versus NP problem. And this is literally what NP means. So theoretically, there is the chance that we could solve certain types of problem, complexity theory, in a finite amount of time. There's also the possibility that it could take an infinite amount of time. Plus neutral, which is, that's the 3 potentials answered. Okay, like I say, you've got 2 opposites, neutral in the middle, and that's the P versus NP problem explained really.